Okay, today we're going to talk about frequency and the remaining trig functions. And actually, we're just going to do frequency. I'm going to take the second part of this and we'll push it tomorrow just to have a little bit more time. I think we're going to be okay. So frequency. Turn to your neighbors and tell them what you think frequency means when you hear what frequency is. Go.
That's how my decimal time. Yeah, it's the time of the previous math lessons we previously learned the previous days.
Okay, what's frequency? Can someone tell me an example of frequency?
Yeah, like the frequency of sound.
The frequency of sound. What other thing?
Graphs.
What?
Graphs.
Graphs. Okay. What else? Anything else?
Frequent timing.
Frequent timing. Good. So like, what does it mean? What does it mean to you when I say, "Oh, this student is frequently getting demerits"?
That means they're real bad kids. They should
Consistently.
Okay, they're consistently. Okay, so now let me see if you could figure out the differences here. Let's say one kid got 10 demerits in 1 week, and the other kid got 10 demerits for the whole school year. Are they both frequently getting demerits?
No.
No. So what's the difference there? Why? What's the difference?
One kid got it within 1 week, but he never got it again. But the kid continuing it over.
One gets a lot and one doesn't.
No, they don't. They get the same, Ashley. 10 and 10 is the same number. Oh, so what's the difference there?
But his are quicker, his are more back to back. The
Ah.
other person's are widespread. They're more close together. That's not what you said.
10 a week or 10 for 1 week?
10 a week. Or 10 in 1 week, yeah.
10 in 1 week.
Wouldn't that be
Yeah.
10 a week considering that?
Okay, so
It's just an example, guys.
So the point is that frequency depends on time. We have to see what happens within a certain time frame, okay? So the student that gets 10 demerits in 1 week is getting demerits more frequently than the person that's getting 10 demerits in a whole year. Does that make sense? Because a demerit might only occur once every so often, where a demerit for a student that's getting 10 in a week, it's like getting 2 a day, right? That's a lot of demerits. Does that make sense, everyone?
Yes.
David can't get over that I said 10 demerits in a week. Why are you smiling so much? Okay, that's good. That's a good quote from Elf. I don't know, Smiley's my favorite. Okay, so, talking about frequency. So someone else talked about music, okay? Let me tell you how frequency works. Frequency is the occurrence of something over a period of time, so you can talk about demerits. There's also like music, okay? So like a note, any note you hear is a certain frequency. So, or even your voice is always projecting a frequency. So, for example, in music, you might have an A note, and an A note has a frequency of 440 hertz, okay? And you're like, who cares about that? But what that means is that in 1 second, a note's frequency will wiggle 440 times in 1 second. Does that make sense? So if I have an A note, I don't know if this is a name. A. Okay, that means the note is squiggling 440 times in 1 second. Does that make sense? That means my vocal cords are wiggling 440 times a second. A. Okay. Also, when you hear the same note, an A note that's higher, A. A. Okay? Did you notice how those are similar? A. A. Okay? What's the difference though? One's higher than and one's lower. The higher note it's the same A note, but it's 880 hertz. Okay, which means its frequency is squiggling even faster, twice as fast in 1 second. Does that make sense? So its period is shorter or longer? Shorter. Okay? That's how you apply it in real life. Okay? So we're going to talk about frequency today. You have to know how to identify it. Okay? That's the goal for today. So here are the steps, and here's the big idea, is that frequency is a number of complete waves every 2 pi units. Okay? So when I think about my unit circle, okay? Think about the sine function, the one we graphed with the paper we folded in half. What was the period of the function after you went 2 pi? No.
1.
Yeah, how many cycles does the, well, let's go back. The graph. What was the period of a sine function? How many pi?
2 pi.
2 pi, right? That means after you go around the circle once, it's going to be done with its first cycle, right? It's 2 pi, right? What happened when our period changed? When it got shorter, it would be more. So frequency is how many times the graph wiggles within 2 pi. Okay? We're going to talk about that, and here are the steps. If you're on the video, you should pause here and write it down. Okay, here we go. So what is the frequency of the function? So this was the basic function from last week, a basic sine function. So what is the frequency? The first thing you need to do is figure out what the period is of the function, okay? So what is a in this function, everyone? What's a here? 1, right? What does a affect in our graph, everyone?
The height.
The height, what's that word? It starts with an A. Amplitude, right? This is amplitude of 1. We don't care about that right now. We care about how squished or stretched the note is, okay? So what's B in this situation? 1 also, okay? So remember a couple days ago I taught you period. Period was 2 pi over your B. And your B is right here, right? This is your B. Okay? So you just plug it in. You're like, okay, if period's 2 pi over B, you're like 2 pi over 1. And 2 pi over 1 is equal to just 2 pi, right? That's your period, right? So either of these two answers is correct for period. But the question is asking for frequency, okay? This is how you do frequency. This is how easy it is, okay? The frequency of this is you just flip the fraction. So how do you flip 2 pi? Well, it's 1 over 2 pi. Meaning that the sine graph, or this sine graph, will go through one cycle in 2 pi. Does that make sense? It's the frequency of its cycle, or its period is, in 2 pi, is only once. Okay? Cool. So let me do number 2 now. So this is actually your final answer right here. Frequency is 1 over 2 pi. Number 2. Y equals 2 cosine of 4x, okay? What's the amplitude of this problem? 2. Do we care about amplitude? No. What is B in this problem? No. It's 4, right? So now we have to figure out the period here. So we're going to start with the period formula. So we got 2 pi over our B, which in this case is 4. And I could simplify this. This could be a period, or we could say that this is pi over 2. Okay? So our period is pi over 2. Okay? But that's not the final answer. We're going to take now our frequency, and all you do with the frequency is you just take the reciprocal of the period, which is 2 over pi. And what this is saying is that when the cosine goes around the unit circle 1 pi, or just 180 degrees, you're going to see 2 cycles happen. It'll go up and down twice. Okay? But this has a denominator of 1 pi, so how do I get this fraction to look like 2 pi? What would I do with the whole fraction to get a 2 pi on the bottom? Multiply by 2. So this is, we could convert this fraction to have a denominator of 2 pi by multiplying by 2. So our final answer could be any of these two. We could say that the frequency is either 2 over pi, meaning it'll have 2 periods within 1 pi, or it could have 4 periods within 2 pi. Okay? Yeah.
Which answer will be on the test?
Either one. They're both equivalent. Yeah. That's why I'm showing you both answers, is because it could be any of these. These are both equivalent, meaning these both mean the same thing. Okay? So like on your AMs or on your test, it could be either. You just have to know the concept of like, oh, okay, it's going to have 2 cycles within 1 pi, or 4 cycles within 2 pi. Make sense?
Yeah.
Awesome. Okay, so since today's Wednesday, we got some new groups. 3s, 3, 3, 3, 3, 3, 3, and 3. We're going to have some math chatting. Just, I want 3s to tell everyone else about number 2, only about how did I figure out the frequency. Okay, ready, set, and go. Actually, before that, let me go show you something on Desmos. So right here, you can see that we're starting from 0 to 2 pi. We want to know how many cycles does this go through from 0 to 2 pi. You'll see that? So starting here, it goes down in 1 cycle, 2 cycles, 3 cycles, and 4 cycles. You all see that? Isn't that what our fraction was? 4 on the top over 2 pi. Or the other fraction, remember Seth asked which answer is correct. They're both correct. Within 1 pi, you could say there are, from 0 to 1 pi, there was 1 cycle or period and 2 cycles or periods, right? Does that make sense?
Yeah.
Cool. So let's see you do a couple more. Let me pull this back up. Okay, so let's see if you could do number 3 and 4, okay? Let's have you do these two with your groups, and I'll come back and show you the answers, okay? Ready, set, and go. Okay, so numbers 3 and 4, ready? So number 3, what is the period of the function, everyone? I'm sorry, not the period. Yeah, no, the period. What's the period of the function, everyone? 1? Okay, so period is going to be equal to 2 pi over 2, right? Which is really equal to what? Pi, right? And then frequency, how would you write that as a reciprocal? 1 over pi. Nailed it, right? So that means there's going to be 1 cycle and 1 pi. How do I write it with 2 pi on the denominator? What would I do? 2 over 2 pi. That's absolutely right. Good job. Okay, so these are all correct answers, right? It depends how you're referencing your frequency. If you're wondering, how many cycles does it have in 15 pi? Because that's what's relevant to you. You want to know how many cycles, so then you would just make it 15 pi in the denominator. It depends what you want it. Math is what you want it to be, not what the answer is, okay? Not just what, like, the normal answers. Number 4, what do y'all think the period and the frequency are? 3 pi over 3, okay? 3 over 2 pi. Any other answers? 2 pi over 3. Okay, here we go. So the period is going to be, we got 2 pi over our b. Our b here is 3, right? So it's going to be 2 pi over 3 for the period. Therefore, our frequency is just the reciprocal, which is, you're going to have 3 cycles and 2 pi, or 3 over 2 pi. Right? Wasn't that easy? Yeah, it's cupcakes, okay? Okay, cool. So that concludes the lesson. Yes, I'll go back.
How did you get 2 pi for the numerator?
That's a formula from a couple days ago. Whenever you find the period, you start with, for sine and cosine, you start with 2 pi in the numerator. Yep. Okay. So here's some closure questions. I'd like to, since we're gonna have a little extra time today, I'd like you to talk to your neighbors. I will be calling on 4 students, actually 5 students randomly. I'm going to call on one person for 1, 2, and 3, and then 2 people on this last one. Okay. Ready, set, and go.